Alright, in this video we are going to go over how this works. So as you can see, I can control the mouse with my right hand here. Take my left hand out of the equation, can move the mouse around just with my hand. It's pretty responsive, as you can see. And then if I bring my left hand back in, we have controls like clicking, and then if you click and hold, you can drag around. We also can right click and copy this text. If I go down here to my desktop and open up my notepad, I can then paste into this notepad, and you can see there's some information in here already. And I can just click and drag this window around, clicking and dragging, closing. So all of this is just controlled through a machine learning algorithm with a cheap webcam and then my hands. So the basic idea behind this is the Google MediaPipe machine learning algorithm. So Google went ahead and trained uh, models to detect hands with something like 20,000 images of left and right hands, and then within this model they can identify different landmarks on your hand, and this is primarily what I'm using to make all of this work. I have integrated Google's model into my code, and then I'm just pulling out the individual landmarks that I'm interested in. So as you can see, landmark number 8 for one hand is the tip of your pointer finger, this right here. And that's what I use to control the mouse. So Google's MediaPipe library is something that can be installed through Python. So I had done that ahead of time, and that's really just what they use for they have a bunch of different options to run models, pre-made models, and you can download uh, pre-made models ahead of time. So I downloaded that, and then as you can see here in my hand landmarker image or file here, if I open this with my hex editor, this is just a big old hex file that contains all the data for the model, like the weights and the balances within the model, and that's what every image is getting run through every time an image is captured. So the MediaPipe API documents contain a lot of good information about how to run these. So I'm running this in live stream mode. That's why I can run it in real time and just I'm constantly capturing this webcam and then running the image from the webcam through the machine learning algorithm to identify hands and where they are in the image. So what this outputs is basically a huge array of data which contains each landmark and then its x, y, and z coordinates within the image, and these are normalized from 0 to 1. So if you can imagine this, all the way on the left side of the image here is going to be where pixel 0 for the x axis, and then all the way on the left is going to be pixel whatever the dimensions of the screen are. So it's really dependent on the image size. And then same thing for y. I believe y is negative, or y0 is at the bottom, and y1 is at the top. So I'm pulling out all this data, and then it's in real time overlaying all that data into this nice little hand that you can see that's overlaid onto mine. So each one of these little points is the landmark that you can see in the image, in this image down here, and then also in the overview image here. You can see all of those landmarks pretty much matches this image. So if I go into my actual code, so you can see I was picking my headset there. If I go into my actual code, there's a few initialization things that I do. It's not super important, but I did a lot of work on this code to pull the data and make it optimized so that I can run, as you can see at the bottom of this screen here, kind of where the mouse is now. This is running at roughly 30 to 60 frames per second, so it's not horrible considering that I'm running every single frame through a pretty complex neural network and then taking the output of that and controlling the mouse with it. It's almost real time. So if I briefly run through the code here, I have a couple functions if you're not familiar with them. It's basically a subset of code that you can say at any point in time, I want you to execute this. So if under the right conditions, all of this code will get plugged in to get run in real time. So uh, as you can see, there's an if statement. So if something happens, I'll run this function here, and then it'll output whatever that function says to do. So if I scroll all the way down here, the main bulk of what's going on here is that I'm initializing a capture from my webcam, and then I'm saying with this hand landmarker object, which is my hand detection model, I'm going to take every frame, put it through the model, which are pretty much these lines here, and if I'm detecting something from that, which is a hand, I'm going to put that data into a buffer and then draw the landmarks on the image. So this draw landmarks on image function, if I scroll up here, utilizes the MediaPipe drawing function. Basically, I changed a couple things, being like the kind of data that I'm interested in, and then it'll draw everything on the screen as it detects something. All of the mouse control and identifying where the mouse should be on the computer based on my finger is code that I wrote. So really the only thing that I took from Google or from this machine learning algorithm is the ability to find the hand and identify the landmarks of the hand, and then everything else is controlled through code that I'd written. So, and was optimized through code that I'd written. So if we go into the analyze data function that I had written, what we're doing here is I'm taking all of the hand landmarks and then identifying if it's the right or left hand. And if it's the right hand, I have a function that has specific controls if it's identified as the right hand. And then if it's the left hand, I have a function that has controls for the left hand, as you can see, like clicking or right clicking. And then if we go into this right controls function, this is actually, there's quite a bit of work here to optimize this, because the data that we're getting from the model is pretty noisy. As you can see on the screen here, if you watch, it's really jittery as I move that hand around. So in order to compensate for that, I have a lot of smoothing functions that take all of the data of the where my finger is in the image and smooths it out over time so that I don't get that super jittery, kind of hard to control input that you see on the webcam image. So let's see, let's go over some of the key things here. So I have my sensitivity, which sensitivity basically just says how far do I have to move my finger in order to move the mouse a certain distance. With a sensitivity of 2, what I'm doing is basically cutting the movable window down by half. So if as you can see, my mouse is all the way over at the right side of the screen here, although my finger isn't at the right side of this image. So I'm cutting off the last 50% of distance here relative to my finger. So that just makes it so that I don't have to move my hands super far in order to get the mouse to move where I need to go. It basically, the reason why it's called sensitivity is because it doubles the sensitivity of the motion. The next variable here is the window size, and this is what I use for the smoothing function, as well as this poly order. So this is based on I'm going to butcher this, but Savitsky-Golay filter. So this just takes an input of a window size and then an order of magnitude of a polynomial, and then it'll, as you can see in this image here, smooth the data based on the polynomial. So it'll apply the polynomial to your data in real time and then smooth it out so you don't get super jagged, rough data output. And then on top of that, as you can see down here, that's where I'm taking my data, applying the filter to it, and then I'm taking the last half of the data from the window size, So if my window size is 12 frames, I'll take 6 frames worth of data, smooth it out with the Savitsky Goulet filter, and then I'll take the average of those last 6 so that I get an even smoother uh, motion. So as you can see, there's a little bit, if I were to move my hand really quickly, it would almost bounce, and that is a result of that filtering. So it'll overshoot a little bit from where my finger actually is, but it's not too bad. I have it tuned pretty well at this point. So then this is actually, this little bit of code here is to prevent a bug that happens where sometimes it just thinks that my finger position in the image is a huge number and then it just crashes. So with this little bit of uh, code here, it prevents that. The way that I can get my finger to, or my fingertip I should say, to mate to a specific location on the screen is using this little bit of code right here. So I'm taking the x coordinate and y coordinate of my fingertip within this image. So let's say if I'm the top left of the image is x0, or I should say bottom left of the image is more accurate. This is x0, y0, and this would be, in this case, x1, y1 up in this top right of this image. What I'm doing is taking my actual screen size in pixels, which my screen size is, I believe, like 2560 by 1440 pixels, and then I'm basically just multiplying the XY coordinates of this image by the number of pixels. So if I'm like right in the dead center of my screen here, the XY output from my model would be about 0.5, 0.5. So if I want to convert that to pixels on my screen, where my mouse should be, I'm going to multiply my screen dimensions by that 0.5, 0.5, and I'll end up with a pixel value of like 12 something, and for my x coordinate, and something like 720 for my y coordinate, which will be the dead center of this image. So now that I can determine where the pixel value for each of these points that's output by the model, I can then just tell there's a nice Python library called mouse, so I can just tell my mouse to move to that location, that pixel location on my screen. So it does all this. As you can see, we're running at about 30 frames per second. So it can do all this math. It can run the algorithm, do all the math, figure out where my finger is, and then apply that to motion of the screen, all within about, in that case, it's like 1 divided by 30, so whatever that may be, if I pull up a calculator here. So in about 3/100ths of a second, roughly, I can determine, I can use the model to find my hand, or two hands in this case, find the position of both of the hands, move the mouse to where it should be, and then also, if I click, I can also, determine that I should be clicking the mouse based on where my left finger is. So if I open this window up again. So that's Python's a pretty slow language. For those of you guys that are not software engineers, Python's pretty slow, all things considered. But I think this is, to me, I find it impressive that all this can happen even at these speeds. If you think about how video games run, right? 30 frames per second is not terrible, especially with the amount of computation that's going on. So I've gone over the mouse control now. Next we can go over how I determine when I should be clicking and right clicking based on my left hand. So it's actually pretty quick and easy. If you, all things considered, it's a little bit more complex than the right hand in some cases. As you can see, this function here that controls left clicking is pretty long. It's about, I don't know, 50 lines of code or so. But so I have a few global variables, each of these, like the status of the click. So if I take my left hand and I click, that right now my left hand is clicked, and then if I open it up, it's unclicked. So I track the status of that using these variables and the time that they were clicked. And then same thing with my right. Right click does the same thing. So what this does is very similar to the pointer finger, is I find the landmarks or the X and Y coordinates of the fingers that I'm interested in, which are my left index finger, my left ring finger, and my left thumb. That's kind of what I've used for my controls. So left clicking is when I touch my two fingers, my thumb and my pointer finger together. And then right clicking is when I touch my ring finger and thumb together. So as you can see, still doing it. And then if I just I'm moving my mouse now, but as you can see, I'm clicking, and then when I let go, same thing. I'm using those XY coordinates and then essentially creating a rule set that says, using these two functions here, I find the distance of the X and Y coordinates of the tip of my ring finger, or a pointer finger in this case, and my thumb, and I say if these get close enough to each other, I'm going to initiate a click. All right. So with my finger distance of 50 pixels, what that's saying is if my fingers get within 50 pixels of each other, 50 pixels being the two dots of my thumb tip and pointer finger tip, I'm going to initiate a click, which is happening right now. And if they move more than 50 pixels apart, somewhere around here, I'm going to release the left click button, so it's no longer clicking. Clicked. Oh, I'm trying to drag something around here. So in that case, we have clicked, and I'm dragging, and then released. No longer dragging. So that's what this finger distance is here. This isn't something I can change in real time, but because the code's currently running, but that's what that number does. So if I come down here once more, as you can see, if my index finger, that's what this delta ITX is. So that's the distance between my index finger and thumb for the X positions. So if that's less than the finger distance, and then same thing for the Y coordinates is less than the finger distance, and I'm currently not clicked, that's what this left click status keeps track of, then I'm going to click the button. And then I'm going to set my left click status to true and just record the time that it happened so that I'm not releasing. I basically have this function here that says we're only going to release if it's been more than a quarter of a second since I clicked. So that removes any erroneous data where sometimes you can see my fingers when I'm closing them down, kind of there's some latency there, so it'll click again even though it's not supposed to, and that's just a matter of the how this model works is that it asynchronously, meaning that there's no time tied to it. It'll run the image through the algorithm. So my code doesn't know when it's going to output the data for where the fingers are and all the hand coordinates are. So I'm saying if there's some erroneous data because it took a little longer to compute than the previous frame, I'm going to wait a quarter of a second to eliminate that. So it makes it pretty reliable, pretty robust. So at this point, as you can see, it works well enough that it's not really an issue. Yeah, so that's pretty much how all of this works. It's I think the key points here to understand are that I'm inputting the image from my webcam here, this image right here. I'm inputting this image, and then through this image, I'm running the machine learning algorithm. In this case, it's a neural network that can find hands in an image. I'm outputting all the data for that for every frame of the video, and I am then going to compute where my finger is. And then if I have two hands in the screen, I can determine whether or not I'm clicking, dragging, and then right clicking, and then yeah, the hardest thing about doing all of this is just finding a way to average all of the information, all the data, so that you get a nice smooth mouse control that's also pretty responsive. So if you're there are ways that you can have things compute in parallel, which is threading, and Python's threading is not real threading. So what you're not actually initiating any computing on another core of the CPU. What the threading does is just says, okay, we're going to open up another virtual thread and then compute those things back and forth really quickly. So you're not truly computing in parallel. What you're doing is saying, I'm going to do this one thing for a little bit, and then I'm going to jump over and do this other thing for a little bit, and then switch back and forth until both things are complete. And if you try to use threading in a situation like this, you'll find that it actually slows down your frame rate and your computation a lot. So you have to basically just run everything um, it, one after another, all the functions, and there are conditional checks for when hands are detected or not. So it's pretty, I would say, all things considered, it's pretty simple, especially because Google just has these hand landmarks available for free. It's completely open source, and they even have implementation guides. So um, uh, there's never really going to be a scenario where you can go onto a, a website like this and just pull all the code and have it work right away. There's a lot of editing of the data output that I need to do in order to get information that I actually care about here. So in an example of this is the print result function. So this is a callback. So what a callback in this case means is that every time I review the information in a frame, I'm going to um, set up another function that gets called once I've reviewed all the data in that frame. So that's what this function is here. So every time I review all the data in the frame and check for a hand, whether there's a hand there or not, I'm going to plug in the result, and then I wrote this little piece of code here that says if there is a result, which means like if there are hand landmarks, XY coordinates that are getting returned, I'm going to put those XY coordinates into a buffer to get pulled later, and then I'm also going to simultaneously analyze the XY coordinate data here. So as you can see, sometimes it can be finicky. If you're moving your hand around pretty quickly, it can confuse which hand is which. So it's good for the most part, but if I move my right hand around and have it get chopped off the frame, sometimes it can mistake it for a left hand and click by accident. But yeah, this is all pretty simple. If you have a little bit of knowledge of Python or really any coding, I think something like this is also, I mean, it's purely just kind of gimmicky. Like, nobody's ever going to utilize something like this. It's just not practical as compared to using a mouse and keyboard, but it looks cool in my opinion. Um, and then, let's see here, accidentally moved that over. Yeah, so all of this control right now is just with my little GUI here. So, um, I don't know. I thought it was a cool, neat little project. Another thing that I'm working on is kind of doing a very similar approach, but using eye tracking instead of hands. So Google has another face landmarker um, algorithm as opposed to hand landmarker. So if I go over here into face landmark detection under Python, it's a very similar thing. The code looks very similar. Implementation is a little bit different, but I can actually show you the code for how that works. Have it somewhat working now. So I'll stop this Python code, and then I've been working on this eye control code here. So if I just get this running, it does a very similar thing, but with face control. And as you can see, it's running super slow right now because I have not optimized this in any way. So the hand identification was quite similar. Before optimization, it would run at about, let's see, right now we're running at half a frame a second, which is not ideal. So once you do a lot of the optimization stuff, you can get up to 30 frames per second. And I think that's the real challenge in a project like this is having things optimized and working properly, working in a way where it's meaningful. So just as a quick comparison, maybe I can actually run these things simultaneously. Oh, no, I cannot. I got a pop-up. So by comparison here, if I start up my hand control, again, you can see how quick this runs as compared to the eye control version. There's really no difference in how the two function, except that I haven't optimized the eye control yet. So yeah, that's this project. I'm intending to do with the eye control. My intent is to figure out where the iris is in the image relative to the rest of your eye. So you can see if I'm looking left or right, my eyeball position doesn't change at all, but where my iris is relative to my eye moves from left to right. So I can use that to do the exact same thing. I can figure out where the center of my eye is, and then the math gets a little bit more tricky there because I'm going to have to project that into 3D space essentially to see where my eye is pointing relative to the screen. But um, then the mouse will just move to wherever my eyes are looking on the screen as opposed to moving to where my hand is. So I think ultimately, if I can get this optimized well enough, it would be cool to play a simple game where the controls are just all my hands and or my eyes, and then I can move around the world without touching the mouse or keyboard whatsoever. So it'll be all controlled through just a simple webcam that's running and the code that's running in the background, which I don't know, why not? Seems neat. But I guess that is all for now. I guess I'll have another update soon with the status of how all this is panning out as far as the eye detection goes. Um, so yeah, if you like this project, I'll continue to make more. I don't know if I'll make YouTube videos for all of them, but if you like them, I guess I'll continue. Alright, thanks guys. See you later.